2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there. It is Mathline and you are at the right place. Whether you're online, whether you're watching us on TV, you are at the right place. I'm Ernie Robertson. I'm your host for this afternoon's session of Mathline. Specialized segments, test prep. You say, what kind of test prep are we working with? End of course test, ACTs, SATs, all of the above. If you're looking for a little bit of help getting an edge on those tests, you come to the right place today. So let's check it out, see what we've got going. We also want to mention that we have Bearden High School students. Those are from Knoxville, Tennessee. Some of those high school kids who are giving us some questions, proposing questions for us. And today, we're going to look at some interesting stuff. Let's see what kind of interesting stuff we've got. And we want to say thanks once again to those Bearden kids helping us out. The power of simplifying and solving. The key word there is power. We're going to look at exponents, and simplify means we're going to take some expressions, simplify them, but then also we're going to look at some equations that involve those powers and work with them. So a lot of interesting things going on today, definitely. Always interesting here on Mathline. But let's see what we're going to do. I think great place to start. Let's go to one of our Bearden students, see what they've got to ask.
Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, it's Hannah from Bearden High, Knoxville, and I need to simplify the expression x minus 5 times 3x plus 2.
Whew, two binomials, which hopefully will make one trinomial. I believe they will. And we've got x minus 5 and 3 plus 2 in those parentheses. We're going to multiply them together. So, and simplify as Hannah has asked us. Thank you, Hannah, for the question there for us. And pretty straightforward. At this point, most of you who are taking EOC reviews and things like that, this one should work pretty easily for you. But I'm going to look at two options. First of all, go ahead and write this one down. By the way, we always say for you folks at home, get your pencil, get your paper, and let's do some math together. And we definitely want you to do that also. Go ahead and pick those up, and we're going to work with them. Whether you're watching us on YouTube, whether you're watching us on TV, get that paper and pencil, and let's have some fun along with us. We're going to use what I call the double barrel distributive property. And what simply says we're going to take x, we're going to multiply it times this entire parenthesis. And then we're going to take the negative 5 and we're going to multiply it by the entire parenthesis. And then we're going to put the like terms together and see what happens. We're also going to refresh your memory on the FOIL process here in just a second, which is probably quicker and even easier. But for those of you who have forgotten and not sure what to do on this, here we go. We're going to take x times 3x plus 2. As I said, we're going to take the x times the entire parenthesis. Then we're going to take this negative 5 or this minus 5 and we're going to multiply it through the entire parenthesis also. So I call it double barrel distributive because we got to do it twice. We got to distribute two different locations here. So let's do it. X times 3x gives us 3x squared. Keep going. Oh, we got to do that x times 2. Don't forget it. You'll be in trouble if you do not do that. So we got 2x. Now let's play with the minus 5, distribute it through, and we're going to get minus 15x, and why not finish up with a minus 10? Life is good. Whew, we've already written two lines of figures, haven't we? But at this point, it's just a matter of simplifying. Want to make sure we do that, catch that at the end. These two guys are the only thing that will come together. They're the only like terms that we have. So we've got 3x squared minus 13x minus 10. So there's one option, my friends, using the distributive property as a double barrel. Now, at home, let's rewrite it, and let's go back to the point. So some of you say, Ernie, I think I remember doing this thing called FOIL. You know, I do too. And we're going to look at that. We're going to see how easy that is once you get the method. Now, we've got x minus 5 again, and we're going to pick it up with multiplying by 3x plus 2. Notice there's nothing in between the parentheses there. That implies we're multiplying. Now, if there had been a plus there, we would be looking for like terms, adding things together. If there were a minus there, so forth. But since there's just space, it's multiplication. So let's FOIL. Everybody remember, what is the FOIL method? First means our x times 3x. Outer, go to the outermost terms in each of these parentheses. In other words, the x is the farthest to the left, The 2 is the farthest to the right. Multiply it and think about it. You said multiply and think about it? Yeah, think about it. Then go to the inner, which is -5 and 3x, the innermost. And then the last would be our 5 and our 2. That's a way to make sure you multiply everything. Notice there's 4 multiplications, just like there was 1, 2, 3, 4 multiplications up here. So the FOIL is just a nice compact way to do the distributive property twice. And hopefully we keep track of it because we got good minds, good memories, good abilities. You say, really? Yeah, I mean it. So we got first, I mentioned that already, that's going to be 3xo. Don't mess it up at this point, my friends. It's got a squared, right? All right, every time, remember, x times 3x. Remember to bring that squared along. Now, go to the outer, and that's 2x. Now, remember I said, think about it. We're going to think about it. Put that 2x in your mind. Go to the inner. You've got a -15. Think about it, because we're going to put those two together because they both have an x. They're like terms. Mental math time. Oh, it's easy. What do you got? -15, and you've got a 2, which gives you a -13x. And now to the last. There we go. The last thing's there. -5 times +2. Well, golly, that's -10, isn't it? Notice, good news. I'm glad there's good news. We got the same answer both ways. This one took a little less space, didn't it? If you got the FOIL down, dear friends, that's a nice way to do a multiplication of 2 binomials when you have it on ACT or SAT, because remember, you're under time constraints there. Now, your EOC, you've got a pretty good bit of time to do those kind of problems. But remember, time constraints, anything that makes life shorter and easier, FOIL will do it for you right there. Get the same answer, too, if you do it up here in your head. Let's take a look at our next one, and before we do that, let's hear, I think Bearden students got that for us there.
Hey Mathline, this is Emma from Bearden High School in Knoxville, Tennessee. Could you please raise the binomial x plus 3 to the 3rd power and simplify the results?
Emma, thank you. Raise the binomial x plus 3, and there again we got those lovely parentheses around it, to the 3rd power, simplifying the results. That sounds kind of complicated. And Emma, it's not an easy question. Thank you for giving that to us today. I was about to jump over her and forget about her, but we don't want to do that. Emma's great to have you with us. And what this basically says, oh, it is so easy to look at that and say, oh, Ernie, anybody can do that. It's x to the 3rd plus 27. No. In other words, you just took x to the 3rd, and then you took 3 to the 3rd, and you were done. Guess what? That's one of the solutions they're going to have for you. And some people will put it down because, oh, that makes sense, because that's simplified, isn't it? Well, we got a little bit of work to do on that. Let's take a first look at it and understand what this means is to take the parenthesis and multiply times another parenthesis times another parenthesis. Oh my goodness. So let's look at taking just 2 parentheses at a time. That's the best way I know how to do it. And then we'll pick up that 3rd one. Yes, some of you are saying, well, isn't there a formula for those? There is. So just one thing I did want to make sure, though, is that we do not think the formula is x cubed plus 27 and say, that was easy. It would be easy, but it doesn't work that way. Sorry about that. We've got to go with parenthesis times parenthesis. You'll see what I mean right off the bat here. Let's do a FOIL, all right? We got it down, all right? First, we get x squared, outer, inner, that's 3 and 3. That's going to give us 6x. And then we got the 9 coming from 3 times 3, which is 9. Well, everybody says, well, that makes sense. I know, but I still have some students who think x plus 3 squared is going to give you x squared plus 9. That's not going to work either. So it gives you x squared and a nice middle, and that middle is very important. Very important because you're going to pick up some more middle when we multiply this little guy times x plus 3. Now, I want to take a little method with you here. We're going to take everything in this big parenthesis, this trinomial, times x. Then we're going to, it's just like distributive property, isn't it? Exactly. We're going to take everything, or we're going to say x times everything in here, however you want to look at it. But we're going to multiply everything through by x, then we'll triple everything, and we're going to line them up. So we make sure we get our like terms to line up. It's really kind of cool. It's a little, what I call a hybrid method of getting through this if you don't remember the exact formulas. And folks, there's so many formulas that run through your heads. I'm not expecting you to remember every single one of them that you've had in Algebra 2, geometry, and all those things. But this one is one you can work out without too much pain and sweat. All right, let's do it here. I said everything times x. So that means we're going to bump up all our x's by power. Are we going to multiply or change any numbers? No, because we got a 1 there. So it's going to give us x to the 3rd, bump up to 6x squared, bump up to 9x. That was quick. And that's the hardest part. The next thing we're going to do, we're going to triple everything. We're going to take 3 times everything. Well, 3 times x squared, no bumping up this time, by the way, with exponents. We're just going to go straight with them. We're going to have 3x squared. Triple time, how about it? 18x, wow, plus it looks like 27. So I want everybody to notice something. We certainly got it right with x cubed and 27, but there's a lot of stuff in between. A lot of stuff that we've got to work with. Piece them together. Let's see what we get. I get x to the third, which is x cubed by some of our methods here. How about it? That's 9x squared because everything's hanging out positive. Then we've got plus our 27x and a plus 27 on the end. And there you have where we are going. Did we leave out anyone or anything? Let's make sure. I always like to make sure we haven't messed up on things. We got that x cubed plus 6x squared plus 9x. That's the first part. Now we're tripling everything. Got to remember the 3, the 18, and the 27. And there, my friends, that is what we're going to say is your final resting place on this one. That's the simplified form. Now, I'm going to throw something at you. What if we put a minus in there? So let's take a look at that problem. Let's take a look at that one. So hopefully that's got our Bearden students happy with that one. But I want to take it a little bit further, all right? Let's see what we've got here. So Emma, you gave me a plus. I'm going to give you a minus. And let's see what happens. The same story. We're going to write them down. X minus 3. And I'm going to separate this one because we'll deal with it in a minute. All right? So we're going to put that down there. And we're going to get foiling. Exactly. So let's do it. Mental math time, right? Let's go x times x. That's x squared. Outer, inner, minus 6x, because negative 3, negative 3. Ah, see there's a minus there. That makes a difference. Tack on the 9. Now, let's play it out. And see, once again, you can't just go and say x to the third, and then 3 to the third, and have x cubed minus 27. Not going to fly, because already we've got some stuff going on beyond that. So let's see what it does for us from here. Let's see where we're going. Again, bump it up. Bump up your exponents. So you're going to have x to the third minus 6x squared plus 9x, because you're working with us at home. That's the way to start. Now, let's negative everything. Now we've got to be careful, because signs are changing. So that's going to become negative 3x squared. Woohoo! That goes positive 18x. And then we got minus 27 here on the end. Interesting, 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 isn't that, my friends? We've still got x cubed, and we still have that minus 27, but we got stuff going on in the middle again. So this time it's going to be minus 9x squared plus, 27x. Now, let's go back and think a minute. That problem we just did, that Emma had, we had x cubed plus 9x squared plus 27x plus 27. So we got the same value, almost. What's the difference? You got a negative popping up here where we had a positive over here, and we had a negative on the end where we had a positive over here. So it does make a difference to the sign. You're going to get this alternating pattern going through there. And this one, as far as we're taking it here with x to the third, it is simplified because you can't add any of these other pieces together. They are no more like term situation there. All right? And I wanted you to notice that because a minus makes a difference. And folks, the parentheses make a really big difference. So be careful when you get one like that. And also notice, if you know that little FOIL method, and then you can look at bumping up and tripling and things like that, this goes through pretty quick. You can get this thing done in 1 or 2 minutes. All right? Now, let's see what we've got coming up our next one here. I understand we got another Bearden student with a problem for us, I think.
Hey Mathline, this is Parker from Bearden High School in Knoxville. I need to solve the equation 3x minus 1 to the 1/3 power minus 6 equals 4. It's supposed to come out even.
Parker, I hope it does come out even because I hate it when they don't come out even, that is for sure. He's got a question, an equation for us here, and it does involve a power. In fact, we've been working with so many powers today. 3x minus 1, this time to a 1/3. And we're going to subtract 6, and we're going to end up equaling 4. That's a mouthful. Let's see what we're going to do. First things first, I always like to attack a problem or an equation situation and say, what do we need to do first? You've got a lot of things going on here. You've got a 3x minus 1 that's going to have to deal with. You've got a 1/3 you've got to worry about. Oh, but we got this little minus 6. That one's easy. That one's easy. So let's do it. Let's move it over by adding 6 to begin with, right off the bat. And all of a sudden, our problem looks a little bit simpler. I think it looks a lot simpler. Say goodbye to the 6's. 4 plus 6 gives you 10. We still have this 3x minus 1 raised to the 1/3 power. Now, some of you are going like, what is a 1/3 power? We thought exponents had to be like numbers, like integers. 2, 3, 4, 1, 0. And then they threw negatives in there and it really got you upset. But now we got a 1/3 power. What does that mean? That means we're taking the cube root. So you could rewrite this, and I'm going to do it, as 3x minus 1. Now you say, that's easy. That's pretty easy. Equaling still to 10, because it didn't say cube root the 10. It just says 10. So here's where we're going. By the way, we are going to make it come out even for you, Parker. I know we're going to. So what are we going to do to take care of this cube root right here? We need to raise this equation to the 3rd power. That's how you offset a cube root. Now, if that had been a square root with just nothing in there, just a square root, you would have squared both sides. But this time, we've got to raise it to that 3rd power. Notice something else about 1/3 and this 3. They are reciprocals of each other. And that's going to come important to you. If these were not a 1/3, you'd be using reciprocal power. You say, whoa, yeah, I say so too. By the way, the reciprocal means we're going to raise both sides to the 3rd power, and that will take care of your 1/3. And since it's going to take care of it, look what we have. We have 3x minus 1. Now, everybody can do 10 to the 3rd, right? It's 1,000. And let's see what's going to happen here. I said, Parker, we're going to try to make it come out even. I think I messed up a little bit on making it come out even, buddy. Nope, I've got a minus 1 here, but it's not going to come out even. You said hope it will come out even. It's supposed to come out even. This one is not going to come out even. So we're going to add 1. That's okay. We can get around it. We're going to have 3x equals 1,001. I bet it was supposed to say plus 1, and we would have had 999. That would have been great. But, hey, it's the way it happens. So let's divide by 3, and we'll go ahead and smash this thing through. That is going to give us x equals, how about it? 333 and 2/3. Let's see if that's right. Let's take it to the calculator and see. 1,001 divided by 3. There it is. That's 2/3. We can still deal with that. 333 and 2/3. Now see what I said. If it had been a plus 1, we would have had 999. Would have been a great 333. But Parker, we threw you just a little bit. You threw me a little bit, I guess we could say. Now, check it real quick. If we stick that back in there, yep, we'll get 1,001. And 1,001 minus 1 is 1,000. Take the cube root. That's what that 1/3 means. Gives you 10. 10 minus 6 equals 1. So it's a good answer anyway. Hey, Parker, thank you for that question. Trying to throw me off a little bit there, I believe. Okay, it did not come out even, did it? Now, we have one more, I think, coming along our way, another one of those things, and let's see what kind of mayhem we can have off this problem. Let's see what Bearden has for me.
Hey Mathline, this is Emily from Bearden High School in Knoxville, Tennessee. I need to solve the equation x minus 1 raised to the 2/3 power equals -4.
Woo, Emily, 2/3 power this time. Oh, you didn't put a plus or a minus or anything on there. Oh, we got a minus 4 or a -4 there. Well, let's take a look at this one, all right? 2/3 power equation. We're going to solve. Going to have fun with it, all right? So let's see what she has sent to me. If I tell you Parker threw me a curve last time, let's see what Emily's going to do. We have 2/3 power. What does that mean? What did we say? We said 1/3 power meant what? A cube root. This is basically, let's take the cube root and square it. Or, yeah, that's what it's saying. Or square it and then take the cube root. That's the idea. And we should come up with a negative 4. Now, that sounds a little suspect to me. But what we're going to do, I'm going to show you what we're going to do here. See what Emily has done. We're going to see 3/2 power here. Because remember I said something a little bit earlier about reciprocals? That's how we're going to get rid of that 2/3. We've got to use the 3/2 power. You say, good night, Ernie, where these crazy exponents come from? So that means also we need to take this negative 4 to the what? 3/2 power. Well, some of you are thinking, does that mean we have to take a square root? Yep, we do. I have to take a square root of a what? A negative 4? Emily, we can't do that. I don't think so. Let's see if the calculator tells us we can do that. Let's see, put in parentheses. Let's try this. Negative 4, I bet we're going to get an error. We're going to raise it to the 3/2 power. Non-real. Okay, so let's go back. Let's go back here. That means there's no real answer to this problem. We can't get anywhere. So let's do one little adjustment, all right? Let's go to an adjustment here. Let's go back to the problem at hand here. Let's rewrite this a little bit, all right? By the way, folks, there are no solution situations in mathematics. This was not a, this was on purpose. This was not one of those things. Did you make a mistake? Did we make a, no. I want you to notice that not always do you get answers, and you cannot take the square root of a negative number unless it goes imaginary, and then it gets really crazy because then you're going to try to cube it. So let us take care of business there. And by the way, it's not a negative 3/2, it's just 3/2 there. I don't know how that negative got in there, except that I probably put it there. Now, let's fix this problem. We're going to have to say x to the x minus 1, and we're going to keep it to the 2/3, all right? But this time we're going to make it go positive 4. That will have an option. And let me go back to why. You cannot take square root of a negative number, which we were trying to do there. By the way, that is now a 3/2, those of you who are just joining us in. And we said forget that, all right? It's not working. So what we're going to do, we're going to now take and raise this just like we were going to do. Use a reciprocal power. 4 to the 3/2, all right? And when we do 4 to the 3/2 power, what do we got going on here? We're going to say the square root of 4, which is 2. That was easy. And then we're going to do what? We're going to raise that to the 3rd. That's one option of doing it. So what does that give us? It should give us 8. Are we good on that? Sound like 8? Let's go with 8. And what's happening over here? These things just cancel each other out beautifully and leave us with x minus 1, which all of a sudden is really a sweet-looking problem. And we'll add 1. And it looks like we've got, I hope we have it, we have a 9. That's 8 plus 1, all right? And let's check. If we say 9 minus 1, we get 8. And what we're basically wanting to know now that I've got all sorts of stuff going on here, 8 to the 2/3, does it equal 4? Well, the cube root of 8 is 2. Square it, you get 4. And a check, all right? So Emily, nice try, honey. We did. We had that negative 4 to the 3/2 power. That wasn't going to fly. So here's what we do. We can adjust it. So we kill 2 birds with 1 stone. We got 2 good problems out of this little problem right here. And again, like I said, not always is there an answer to every solution, all right? Not always an answer to every problem. There's some solution. In this case, it's no solution that we had here. But down here, we actually come up with the number of 9. Now, one last one for the road. Do we have time, guys? 2 minutes. Let's just take a look at a power problem here and see if we can analyze what we would do with it. First things first, it says solve the equation 3x cubed minus 30x squared plus 27x equals 0. You thought it was going to be a quadratic. Well, it's a cubic. It's got the 3rd power in it. But notice we have a common factor. We have a GCF, a beautiful GCF of 3x. Let's pull it out of there. And let's see what we're going to get. We're going to get x squared when we divide 3x out of 3x cubed. We're going to have minus 10x. And no x squared anymore. Now that's gone. All right, it's down to x. And last but not least, we have plus 9 here. My question is, will we be able to factor that? We certainly can. How about it? 3x stays alone, but I don't lose that because I got an x there. I got to have a solution from that. We're going to have x minus, it looks like 9, and x minus 1. This one's easy, right? Because remember, each of these parts has to give you a 0. So if 3x equals 0, x is 0, boom. X minus 9 equals 0, that's x equals 9, that's nice. X minus 1 equals 0, and x equals 1. There are your solutions. There are 3 of them. Hey, 3 power of 3. There we go. Hey, thank you, Bearden High School. Some of you followed me up a little bit there. Some great questions. We appreciate you guys. And also, thank you for tuning in today, whether you were online, whether you were watching us on TV, whatever you were doing. We thank you, and hopefully you got some good lessons out of this. Again, test prep, we're working on this for a little bit longer, and we are always there on Mathline Online with YouTube, and we're also available, still Facebook, and you can still email us, all right? So, but thanks for tuning in today, wherever you might be tuning in from, and you know what? You know what? We're going to see you again next time, and look forward to it.